Okay guys, today we are on page 7 of your chapter 7 note packet, the 7.3 notes. We're going to talk about the ways that we can prove triangles similar. So we had 5 ways to prove congruent. There's actually only 3 ways to prove similar. Our first one is angle-angle similarity. If 2 corresponding angles are congruent, then the triangles are similar. So we have to have 2 angles that are congruent. If 2 are, automatically the third one has to be because we have that requirement of the triangle equaling 180 degrees. So we just need to see if we can say that they're similar. If they are, we want to write a valid similarity statement. So if I look at these first 2, well, I already have a set of angles. I have 75 congruent to 75, 31 congruent to 31. So I have 2 sets of angles that are congruent. B and E have to be, again, because of that 180 requirement. So I can write my similarity statement. Triangle ABC would have to be similar to, well, since A is 75 and D is, I have to put D first. B has nothing, E has nothing, put E, and then C is 31, so F. Number 2, if I look at it, I just have one set of angle marked congruent, V and Y, but if I'm looking at my picture, you guys should be noticing we have vertical angles, which are always congruent, so I can mark those. Therefore, my triangles have to be similar. So I could say triangle VXW, similar to, since I did V, I have to do Y. Since I did X, I have to do X. And then I have Z. All right, let's look at side similarity. If all sides, so we don't get to say just like 2, if all sides are proportional, then the triangles are similar. And like I said, proportional means I'm going to get a fraction that's the same across the board when I reduce my fraction down. If it's not reduced, it's not going to work. We need to make sure it's in simplest terms. So if I'm setting up my proportions here, 3 is my smallest number, so it needs to go with the smallest number in the other triangle, which is 6. 4 is my middle number, so it goes with my middle number, which is 8. And 5 is my largest, so it goes with my largest number, which is 10. 1/3 is 1/2. 4/8 is 1/2. 5/10 is 1/2. All of these reduce down to 1/2, which is telling me that my sides are proportional because I'm getting that same fraction, so I can say that they are similar. If I go Q, P, R, smallest to middle to largest, I need to repeat that. Smallest is TS, middle is SU, and then longest is U to T. And it might help for you to color coordinate. So if I made these both red, these both green, once I pair them up, and then blue, and then you can trace the colors. That might be helpful. We don't have tick marks because they're not congruent, so that might be something that throws you off. For some kids, they make up their own marks, so let's say like 1 squiggle, 2 squiggles. And that's them saying that those are proportional. You could do that. You're not going to see that in any textbook or anything, but you could do that. On number 4, if we do that, so I'm looking for my smallest side. My smallest side is 30. Goes with my smallest side, which is 24. My middle side is 32, going with my middle side, which is 25. And my longest is 35, going with my longest, which is 28. Also notice how I'm always starting with the same triangle and keeping that same triangle as my first triangle throughout the whole thing. So 30 over 24, that would reduce down. So if I reduce these, this is going to get me 5 over 4. This 32 over 25 has nothing that can reduce, and then 5 over 4. So 2 of them work, but 1 doesn't, which means I am not similar. All right, and then our last one is side angle side similarity. So this one, it says if 2 corresponding sides are proportional and the included angle is congruent. So it's that same nature that we saw. That angle has to be trapped just like we saw with the congruency. But again, our angles are congruent, our sides are proportional. So looking at that first one, I have an angle trapped between my 2 given sides. One of my sides is KJ and NM, and then my other side is KL and NP. Notice how that angle is trapped. So now I just need to check if my ratios are the same. So if I'm looking at 8 is the smallest over 6, which is the smallest. 20 is the largest over 15, which is the largest. That would reduce down to get you 4 over 3. and 4 over 3. So they work, so I can say that they are similar. So I would say triangle JKL similar to triangle MNP. All right, let's try number 6. We saw an example of this the other day, but I have one triangle trapped inside. That was a horrible job. One triangle trapped inside of the other triangle. So my angle that's congruent is going to be angle A because it's shared between both. And then I'm looking at my sides. Well, just notice that for these sides, like they are going the whole length. So that 25 I need and that 21 I need. If I look at my smallest side is 12 over my smallest side, which is 21. And then I'm looking at 15 over my largest, which is 25. This would reduce down to 4 over 7, and this would reduce down to 3 over 5. Those are not the same. So I have an angle, but I don't have the sides, so this one would be no. All right, guys, so those are the 3 ways to prove triangles similar. What I want you to do is I want you to work through pages 8 and 9. That is a total of 18, and just work through them and see if you can figure out if they are similar or not. Make sure you pay attention to those parallel lines on number 1 and 2 of your angle, but notice how they've split them up into the ways that you're going to. So the first block is angle, second side, side, and the final one is side, angle, side. And just try your best there. See if you can figure out if they are similar or if they aren't, and write that similarity statement if they are. Your angles must be congruent, your sides must be proportional, which is just getting that same fraction when you reduce it to simplest form. If it's not in simplest form, we can't compare it. And so bring those completed to your class meeting, and please bring any questions you may have as well. We will check those off in your class meeting.